All right, so here's your Unit 8 AP Classroom Assignment support video to try to get you the best grade as you can. It's essential that you show your work and explain your answer on this piece of paper and then take a picture of your work for each question. That will give you 100%, even if you got it wrong, that you showed and that you're doing work to try to get there. And then, of course, if you get the answer correct, when you submit it on AP Classroom Assignment and your score comes to me, then that grade also. So there's two parts. All right, here we go. If P at t is the size of a population at time t, which of the following differential equations describes a linear growth in the size of the population? So, a couple things we need to recognize. A differential equation has to do with the rate, slope. And if it's a linear growth, what does that tell you about the slope? And you have to understand this. For a linear relationship, the slope is constant. That means the number never changes over time. The rate never changes. So if I look at A or B or C or D or E, which one of those is a constant that no matter the time, the number would stay the same? That's you. Where am I pointing towards? Number 2. The slope field for a certain differential equation is shown above. Which of the following could be a specific solution to the differential equation? So, if I look at all of these, what I'm going to do is I'm going to take and recognize that for these solutions, I'm going to know what the curve looks like. So like for y equals x squared, what is the solution? What should it look like? For y equals e to the x, what does that curve look like? Where y equals e to the negative x, that's a decaying exponential. What does a decaying exponential look like? Cosine x. Right? It's a wave. Ln x. That's what a logarithmic curve looks. So we need to know our functions and what the curves look like. Then you're going to go back and you're going to draw. So find something and draw what the curve looks like, right? So take some point and draw the picture using a point. And then see which picture could be which one of these. And then once you found the picture that goes with it, then circle it. All right, number 3. If A and B are positive constants, can you evaluate a limit as x approaches infinity? So when I do that, I'm going to separate the numerator and the denominator. I'm not going to write down infinity over infinity. So as I put in large numbers for x, if b is a positive constant, then this is going to infinity. Same thing here. The limit as x approaches infinity of the denominator. See if I wrote that down right. If A is a positive constant and you're plugging in like 1 million, 1 trillion, so on, where is this going to? So even though it's a logarithm, it's still increasing, even though it's increasing slowly. So it is still going to infinity. This is L'Hopital's rule of indeterminate situation. So what do you do when it's indeterminate? And it's L'Hopital's rule is you take the derivative of the numerator and denominator. So what's the rule for the derivative? So it's a fraction, so it's bx plus 1, and then the derivative of that is just b. So if b is a constant, the derivative of bx would be b, and the derivative of 1 is 0. And then the same thing for the denominator. It's ax squared plus 3, and then the derivative of that, well, you have x squared, so it's 2 times a, so it's 2ax. That's the derivative. All right. And then we're going to make that look proper by multiplying times the reciprocal. So you have b over bx plus 1 times ax squared plus 3 over 2ax. And again, we try to see what's going to happen as that goes to infinity, and then keep working at it and see which one of these answers is going to match as you apply L'Hopital's rule. So nothing simplifies here. So if I plug in infinity, it's the x squared part that, and then there's an x squared underneath here. Let's just simplify this real quick. So if you can find the power terms. So if I multiply this together, I get a times b x squared plus 3b. Remember, I'm just distributing, right? And then same thing here. I'm going to distribute the 2ax with the bx. So that's 2ab x squared. And then 2ax times 1 is 2ax. Now, to understand the right-hand behavior here, we're going to understand the power term of what's happening. So this is power term over power term. Or we can take the derivative again. So if I go power term over power term, I get ab x squared over 2ab x squared. I wonder, in terms of power term over power term, if you divide this out, I wonder what answer you would get, and that could match one of these answers here. So do the work, finish this off, and then find the answer there to number 3. All right, look at number 4, please. I'm going to close my door in a second right now. All right, sorry about that. So let's do number 4 right now together. So number 4 is the limit as x approaches infinity of this, x cubed over e to the 3x. So recognize that we're going to separate the numerator and denominator and see if this is indeterminate to begin with. So if I look at the numerator, as I plug in large numbers for x, this is going to infinity. If I look at e, that's not negative, that's just e to the 3x. As I plug in large numbers for x, this is also going to infinity. So this is indeterminate. So that means I'm going to take the derivative of the numerator, that's 3x squared. The derivative of the denominator, which is e to the 3x times 3, it's still going to infinity. And so as you do this work, and we're going to continue to apply L'Hopital's rule, this is 6x, and this is going to be 3e to the 3x times 3. Again, it's going to infinity. Eventually, it will not be indeterminate. So you take the derivative of the numerator, take the derivative of the denominator, and now it's no longer indeterminate. And recognize the denominator is increasing faster than the numerator. So what's the answer when the denominator is increasing faster than the numerator? So as I plug in large numbers for x, the answer that this is becoming, it's getting closer and closer and closer to what answer? So turn the page and recognize which one of these answers is it getting closer and closer and closer to. All right, number 5. Again, it's a limit question in number 5. So the limit as x approaches 0 of this. So first, I'm going to separate the numerator and denominator. So to evaluate this limit, plug in 0 for x, and then evaluate. So the limit here is 0. If I look at the denominator, what's the valuation of this limit? Just plug 0 in for x, and the answer is 0. This is indeterminate. We know we're never going to write down 0 divided by 0. And then we can apply L'Hopital's rule. So if I'm going to apply L'Hopital's rule, you take the derivative of the numerator, e to the x subtract 1. The derivative is e to the x. the derivative of just x is 1, and now it's no longer indeterminate. Plug 0 in for x, evaluate, and then find the answer that would match it. Done. All right, 6. Let g be a continuously differentiable function with g at 1 equaling 6 and the derivative of g at 1 equaling 3. And then what's this limit that looks kind of intimidating to begin with? So to evaluate this limit, I'm going to separate the numerator and denominator. So this goes from 1 to x, g at t dt. And so how do I evaluate this? So substitute 1 in for x. If I'm evaluating a definite integral and it's going from 1 to 1, that means there's nothing to find the area under. 1 to 1, the area would be 0 because it's not going 1 to any other number. So if it stays at 1, there's no area to find underneath the curve. That was the definition for 0. So if that number stays the same, then the answer is 0. In the denominator, the limit as x approaches 1 of g at x subtract 6. Well, if I plug 1 in for x, we have g at 1. And we're told that g at 1 equals 6. So 6 take away 6. This is indeterminate. But we're not going to write down 0 divided by 0. So if it's indeterminate, we're going to apply L'Hopital's rule. So the limit as x approaches 1, we're now going to take the derivative of the numerator and denominator. So how do I take the derivative of the numerator? So if it's the derivative and integration, this is the fundamental theorem of calculus, the sequel, part 2. It's just a substitution question where you plug that in. So it's just a substitution question where you plug x in for t, and that's it. So it's just a substitution question. So the derivative of this is just g at x because there's a constant there. So that's all it is. It's just g at x. And then the derivative of the denominator is g prime at x, and negative 6 is 0. So if you took the derivative, this is what we got. And then it says, what's the limit as x approaches 1 of g at x? Just substitute in. What does g at 1 equal? There's your numerator. And then what's the limit as x approaches 1 of this? G prime at x. Well, just plug 1 in. And what does g prime at 1 equal? So you have your numerator and your denominator. You simplify it and then find the answer. Number 7. What's the limit as x approaches 0 of this? So you can tell that this is L'Hopital's rule. It's indeterminate. So that means we're going to take the derivative of the numerator and denominator. So if you plug in 0 for x, you get 0 over 0, which is indeterminate. So we're going to take the derivative. So that's 12x to the 5th plus 18x squared. Here, that's 20x to the 4th plus 9x squared. And then we're going to continue that. Still indeterminate. So you continue to take the derivative top and bottom until it's not indeterminate. So if I continue here, this is 60x to the 4th and 36x. In the denominator, it is 80x cubed and 18x. Still indeterminate. So if I plug in 0 for x, top and bottom, indeterminate. But this is the last time I need to do this. So now again, I'm going to plug it in. So if I plug in 0, if I take the derivative again, 4 times 60, 240 x cubed. Now the derivative here for 36x is 36. The denominator, the derivative, is 240x squared plus 18. So I said, hey, now is this indeterminate? So when you plug in 0 for x and then simplify it, is not indeterminate. So what's left over that could be the answer? And where could the answer be here that could match it? So show your work, tell me the answer, find the answer, circle it, and then when you go online, you can submit that answer in. All right, that was number 7. Number 8. In number 8, you have a slope field. And it says, shown above is a slope field for which of the following differential equations? So I'm going to expand this just a little bit so we can see it, even if it's a little blurry. And so which one of these could match this? So what I do first of all is I recognize the y-axes. They have all the slopes for the y-axes. The slope is 0. It's horizontal. And on the y-axis, that's when x is equal to 0. So when x is 0, what should the answer be for the Diffie Q? And then I can cross out some bad answers. So when x is 0, all the slopes are 0, all the way down. So if I plug in 0 for x, that one's okay. 0 for x, that gives me 0. 0 for x, that does not do that. 0 for x, that gives me 0. And then this one doesn't work. Okay, so now I'm down to 3. And now I'm going to pick out another point and test it. So what's another point I could test to see if it works or not? So I'll circle that one right there. So at that point, and if I look at the scale, 1, 2, 3, 4, 5, 6. So here, let me pick out the one beside it. And the one beside it right there. So this one right there is 1, 0. So if I get the answer 1, 0, what does it look like approximately the answer is? So the answer better be pretty close to -1, right? In terms of the direction it's going. It may not be exactly, but it definitely better be negative, right? Kind of close to -1. So can I eliminate any bad answers? So if I plug in 1 for x and 0 for y, does it give me the right answer? So if I plug in 1 for x and 0 for y, simplify it, does it give me the right answer? So I look at that one. If I look here, 1 for x and 0 for y, does it give me a negative answer? For part B, right? How about this one here? So 1 for x and 0 for y, does it give me the right answer? So I think you can like start eliminating. And now we got to do it one more time. So pick another point, not here. Perhaps pick another point completely else other than that. So we can pick another point, let's say completely in the first quadrant. So like this is so like right here. In fact, we could have done that already. So notice that when the slope here is 0, when the y coordinate is what number right here? So this scale is by halves. So when y is 1, the slope is 0, right, across. So of what's left, when y is 1, which one would give me the slope of 0? When y is 1, which one would give me the slope of 0 here? So I want you to notice that when y is 1, you're going to get 0. And when y is 1, you're going to get 0. So that doesn't help me eliminate. So again, I'm back to this idea of picking out a point in a quadrant and testing it out. So let's say I try 1 and -1. That's right there. 1 and -1. The answer better be pretty close again to -1, right? And something like that. But it should be negative, right? Maybe -2. But if I plug this in, 1 and -1, does it give me a negative answer? Because it needs to. So if I plug in +1 for x and -1 for y, does that give me a negative answer? How about here? If I plug in +1 for x and -1 for y, and then keep trying to see which was going to work. So this one's going to change when the x is negative. See how similar they are? It's when the x is negative that it's going to make a difference. So if x is negative, so that means on the left side. So if I pick a point here, right here, so that would be -1 and -1. You got to pick a point that allows you to eliminate answers. So -1 and -1 right there. The slope is negative, whatever that may be. It looks like it's -2 or whatever, but it's, sorry, negative. Does that look negative? Sorry, that answer is positive. So if I plug in -1 and -1, that better give me like +2 or thereabouts. So when I look here, I'm going to plug in -1 for x and -1 for y. Does that give me a positive answer like I want or a negative answer? Same thing here, -1 for x -1 for y. I need to get a positive answer. So decide which one's going to be crossed out and which one is your right answer. All right. Number 9. So for number 9, number 9 is at the bottom of the page, but then the next couple pages are the actual slope fields. So which of the following is a slope field? And it's x divided by y. And which one could be it and how you could eliminate it, right? So the first thing I notice here is that when y is 0, the slope is what? Undefined. Okay? So when I look at each one, the first thing I look at is that. Can I cross out any bad slope fields? This would mean the x-axis should be undefined. So look at A, look along the x. Look at B. Look along the x-axis. Look at C. Look along the x-axis. Oh, it looks empty. Look at D. It looks empty. And then there's even an E, isn't there? And E, it's empty. So I already eliminated A and B. So if it's dy by dx, if this is the slope field, what's another point that we could pick is that if it's 1, 1 and you put it in, the slope better be 1, right? Like this at 1, 1. So let's go. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So every half. So at 1, 1, it would be 2 to the right and 2 up. That looks okay. So now let's look here. 2 to the right and 2 up. That looks bad. That's not the slope I need. So D is wrong. E. 2 to the right and 2 up. So now we're down to 2 possibilities. So what's another point where we could actually do negatives in terms of it? It's x divided by y, right? X divided by y. Okay. So let's make one of these quadrants. So like quadrant number 4, 1, -1, and maybe that will help. So 1 down, 1 to the right, and 2 down. So this one right here, notice the answer is negative, and it's pointing down. So that one looks okay. So the answer here would be like -1. So this is the slope I'm looking for at 1, -1. So go 1, -1, that's okay. I hope I can eliminate something here. So 1 to the right, 1, oh, look at that, right? They both look similar. Let's go to another quadrant. Don't give up. So what's another one we can try until we find a mistake? So let's go and let's look at this one. -1, -1. So the slope for -1, -1, if you put it in, would equal +1. So this is what the slope would look like, right? For +1. So can we go to -1 and -1? Is that right? That looks okay, right? How about the other one? If I go -1 and -1, does that look okay? So -1, -1, is that positive? All right, we're going to pick out another point until we find a mistake in terms of what's different about these. So find one that looks different in the quadrant. So I get the look of this and the look of this. This is a hyperbola, pointing up or down, or a parabola. And so which one would be different? Which quadrant looks different? That way I can take a point and then see one has a positive slope and one has a negative slope. So in quadrant 1 here, they all have positive slopes. Same thing here. Okay, so if I look at something that I need to find a difference here in terms, because if I follow it, they have a similarity except for the sides. And so I need to take a point along the sides because that point is going to be different along the sides. So let's say that I take a point like 5 and 1. See that right there? So that's 5 and 1. Now, if I took that point, 5 and 1, into here, The answer should be 1 over 5, which is a very flat line. Does that look like the correct slope for 5 and 1 if you put it in? Right? So if I look at the correct slope, look at 5 and 1 here. Did I do it again? It's x over y, isn't it? Is it x over y? I think I did it again. So for number 9, where did it go? Oh, here. It's x over y. Why am I writing it wrong? Okay. So it's x over y. So if that's true, the slope better be 5, right? Which is super steep going up. So if I look there, that one actually looks, that one actually looks okay at 5, 1. How about over here at 5, 1? So if I look at 5, 1, it also is a steep one pointing up. So I need to see something that's dissimilar. All right. Well, I know what I can pick. Right here. Man, I'm going to find it. See this? 5, 5, right here. 5, 5. If I go 5, yeah, this is right. So if I go 5 divided by 5, the answer is at 5, 5, the slope is 1, right? It points up. And at 4, 4, and at 3, 3, and at 2, 2, the slopes are 1, right? Do you see that diagonal right there? If I go to 5, 5 here, that is not a slope of 1. So we finally found a point that's different in each one and tested it. And then if I double checked and go, well, how about 4, 4, 3, 3, 2, 2, 1, 1, negative 1, negative 1. Like there's a diagonal where the slope is 1 all the way through that diagonal when x and y equal each other. So what's the only one then that would match? All right, I even just gave it to you, just because. Number 10. The rate at which a quantity m of a certain radioactive substance decays is proportional to the amount of substance present at a given time. So proportional means it's multiplied by a constant. Which of the following is a Diffie that could describe this relationship? So proportional means we take that constant and we multiply it by the amount of substance present. So that would be the y coordinate, or in this case, the y coordinate is the m. So if I take the proportional and use the variables that were given, the amount present at a given time is what m is. So if I take the proportion times m, that would be one that would match. So k could be any constant, any number, times m. So which one would be the correct one? And then I go, okay, nope, nope. So what's left then after that? Well, one's negative and one's positive. So anything here that describes something that I should be aware of that could tell me if it's positive or if it's negative. And then circle the answer that would match. Number 11. All right, in number 11, it says the slope field for a certain differential equation is shown above. Which of the following about x in that solution to the Diffie must be false? Okay, so if I look and then if I sketch a solution here, it kind of has this feel to it, right? That's the, in terms of what's happening. And so it says the graph at f at 1 and negative 1 is concave down. So can you find 1 and negative 1 and see if it's concave down? So look at 1 and negative 1. Is that concave down right there? Yes. And we're looking for the one that's false, right? How about the graph at negative 1 and positive 1? So if I look at negative 1 and positive 1 right here. So negative 1 and positive 1. Look at the shape here. Is that shape right there, is it concave up at negative 1, 1? Look at the smile. Yes. Okay, how about C? The graph of the particulars through 0, 0. Well, I kind of went right through 0, 0. is concave up from -1 to +1. So from -1 to +1, is this concave up all the way through? No, because this part's concave down. So from -1 to +1, there's a part that's concave down. How about the last one? F at 0 equals 0 is a point of inflection. So the concavity changes there. Is that true? At 0, 0, does it go from concave up to concave down? So you pick which one is the false answer out of all of these. So which one is the bad, false answer out of all of these? All right, turn the page. Number 12. The slope field for a certain diffie-q is shown above. Which of the following could be the particular solution to that diffie-q, where y at 0 equals 0? So here we are at y at 0 equals 0. And what does the picture look like here? And what does it look like here? And what is that the curve of? This is a decaying exponential. And notice these horizontal lines here. So this is a decaying exponential where there's like an asymptote right there at y equals 0, 1. So look at these and see which one could match a decaying exponential with the correct one. So I'll let you think through, right, which one it could be. So these two obviously are not decaying exponentials. Think through here, which one could be the right answer in terms of that decaying exponential. And if you need to, graph these pictures in Desmos and see which one could match this picture. All right, number 13. So in number 13 it says, shown above is a slope field for which of the following diffie-q's? So what do I notice about this slope field before I go to the equations? Well, the one thing I notice is along the y-axis, it's empty. So that means the slope is undefined when x equals what number? What does x equal along this axis? So when x is 0, the answer better be undefined. So look at each one and tell me which one shows undefined when x is 0. And then circle it. That's all we need, actually. Number 14. Which of the following is the solution for this diffie-q? And it's dy by dx equals e to the y plus x with the initial condition y at 0 is negative ln 4. So I'm going to show that over here on this side. So it's dy by dx equals e to the y plus x. All right, here we go. How do you solve a diffie-q? And then you're going to match it over here. So step 1, we can multiply both sides by dx. But then the next step is we need to know how to separate the variables. So we need to know exponent laws. That when we're adding, we could actually write this as multiplying with the same base. So it's like the anti-exponent laws going backwards. But by writing it this way, we can then divide and separate the variables. Now I'm going to write this calculus friendly. So it's e to the negative y dy, e to the x dx. And there you go. Step 1. Step 2 is we're going to integrate both sides. So the derivative of negative y is negative 1, so it needs a negative. So it's negative e to the negative y. Here, the antiderivative of e to the x is e to the x, and then the constant. If you like, at this point, you can actually plug in to find the constant. So it says the point is y at 0 equals negative ln 4. So y at 0 equals negative ln 4, right? So at this step, we can plug in that value. So x is 0, and y is negative ln 4. So can you simplify this? Let's see if you can. So a negative times a negative obviously is positive. E to the 0 is 1. and I want to get C by itself. So E and ln undo each other. So I want you to solve for C. You can do that. And then once you have that answer, come back here. Put that answer right here for C. So put that answer in here. And then you're going to divide everything by -1. And then you're going to write this as a logarithm. That's why you're going to get these answers. And then once you've written it as a logarithm, one of these answers is obviously right. And the other ones are not. So find the one that's obviously right. Maybe even looking at what the constant is. And then so finish it off from there. And then circle the right answer. Number 15. So at number 15 it says e to the, I think it says 3x, right? Oops, this one. Yeah, so e to the 3x, subtract 5x plus 7. So for these, I got to take the derivative, because it says the second derivative, subtract 3 times the first derivative, subtract 15, better equals 0. And I need to know the first derivative, the second derivative, and then plug in to see which one is true or false. So to do that, I need to know the first derivative. So that's e to the 3x times 3. The derivative of -5x is -5, and the derivative of 7 is 0. And I need to take the second derivative. So that's 3e to the 3x times 3, and then -5 would be 0. So that's 9e to the 3x. Okay. And then it says, if you go for each one, so each one we have to test out until it's right. So the second derivative, 9e to the 3x, subtract 3 times the first derivative, subtract 15 equals 0. So you just plug in the second derivative, plug in the first derivative, and minus 15. Simple, multiply it out. Is it true? You're done. If this is not true, then you do the work for B and C until you find the one that actually equals 0 and works. And then circle the one that's true. All right, number 16 is our last one. Here we go. A curve has a slope 2x plus 3. That means the diffie-q is that. Slope means differential equation. So the differential equation is that. Which of the following is an equation for this curve if it passes through 1, 2? So I need you to solve this diffie-q. That means you separate the variables and you do the antiderivative. So I'm going to believe you that you can do this. So you separate the variables. It's already separated. Do the antiderivative and make sure it's plus c. And then plug in to find what c equals. And then keep going to get y by itself. And then find out which one of these is the solution to it when you do the work. So I'm going to be looking for I want to see if you can do the antiderivative here. And if you're plugging in 1, 2 to find C, and then find the solution and circle it. That's it. You just did AP Classroom Assignment Unit 8. I'm super proud of you. I hope this helped, and I hope you get an A on this assignment. Mr. G Math, over now.